Shaft is a rotating or stationary member having a circular cross-section much smaller in diameter than the shaft length and having mounted on it such power-transmitting elements as pulleys, gears, belts, chain cams, flywheels, cranks, sprockets, and rolling elements like bearings. It has several classifications like main shaft, line shaft, transmission shaft, machine shaft, axle, spindle, counter shaft, jack shaft, and head shaft. Axle is a stationary member carrying rotating wheels like pulleys and etc. Spindle is a short shaft or axle on machines, while machine shaft is the shaft which is used to transmit power between the source and the machine absorbing the power. While line shaft or main shaft is the transmission shaft driven by the prime mover. And lastly is the counter shaft, jack shaft, head shaft, and short shaft is the transmission shaft intermediate between the line shaft and the driven shaft.
For number 1, compute for the diameter of a line shaft to transmit 25 horsepower in a speed of 225 rpm and the design stress is 6 ksi. Since we have the given power and speed, we can use the formula 2 pi Tn to find the torque. When we derive this, became P over 2 pi n. Then substitute the given P is 25 HP. Then we use a conversion factor of 33,000 for the torque to become pound-inch. Then we convert it. Then 2 pi RPM is 225. And now the torque is 7,002.82 pound inch here. So we can solve now for diameter. We can use the formula of 16T over by pi d cube. When we write this, became 16T over pi stress. Then substitute the given cube root of 16 times 7,202.82 all over by pi 6,000 psi. Then the diameter is equals to 1.81 inch or 1/7 over 8 inch. For number 2, a line shaft having a diameter of 2 inches rotates at 180 rpm and having maximum torsional deflection of 0.08 degree per feet length. Find the horsepower. We need to find the horsepower using the formula of line shaft. The formula of line shaft is d cube n over by 53.5. Then substitute the given. D is 2 inch cube. The RPM of 180 over by 53.5. Then the horsepower required is 96.92 HP or 27 HP. The answer is letter A. For number 3, compute the line shaft diameter to transmit 12 HP at 180 rpm with torsional deflection of 0.08 degree per foot length. So we need to compute the diameter. Since we have the given power and speed, we can use the formula 2 pi Tn to compute the torque. Then we can now substitute directly the given. And T is equals to, well, we will use the conversion factor. Since of 33,000 since it is the RPM is naka per minute. 2 pi the speed. And T is equals to 4201.6 69 inch. Then the next is, ang kailangan naman natin makuha ngayon is, pwede nang maubos yung diameter. Pwede natin, since may mga given tayo ng degree or the torsional deflection, yung length and yung rigidity, pwede natin gamitin itong formula na torsional deflection is equals to TL over GG. Ang formula ng J is I over 32 d raised to 4 since it's circular, solid circular siya. So, we can now substitute the given d is equals to 32 by raised to 1 over 4. Substitute the given 32 times 4201.69 times the length 12 inch over by pi times 0.08 degree. Then we multiply it to pi over 180 para maging rad. Then the modulus of rigidity is 12 times 10 raised to 6 psi raised to 1 over 4. And the diameter is equals to 2.35 inch. The answer is letter C. Number 4. Determine the diameter in inches of a small steel countershaft that delivers 13.31 HP at a speed of 15.7 rad per second. The material allowable design stress is 8.5 KSI. So first, we need to find the torque. Since we have the given power and the speed, we can now use find the torque. T is equals to P, then the speed, the angular speed. Angular speed is equals to 2 pi n. So we can use this. P is equals to 13.31 multiplied by the conversion factor of since this speed is in per second. Here we can use the conversion factor of 550 to pound per second. Then we convert it to 15.7 rad per second. And the torque is equals to 5595.29 pound inch. So we can now compute for the diameter. You can use the formula. Since we have stress, we can use the formula. Stress is equals to 16T over pi dq. Then we can convert it as D is equals to cube root of 16T over by pi stress. Then substitute the given cube root of 16T, the value of torque is 5595.29 pound inch over by pi, the stress of 85 psi per pound per inch cube. Then the diameter is equals to 1.5 inch. The answer is letter B. Number 5. Compute for the diameter of an overhead crane travel shaft that transmits 10 horsepower of the electric motor at gear reduced RPM of 150 and with torsional deflection of 0.06 degree per feet of shaft length. So now we need to find diameter again. The first thing we need to do is, since we have the given power and speed, we need to find the torque. P is equal over 2 pi n. Substitute the given. T is equals to the power of 10 horsepower. Then we multiply it to conversion factor of 33,000 foot-pound per minute, since our speed is in minute. Then multiply by 12 inch over 1 foot to cancel the foot here. And for the torque to become pound inch rather. 2 pi over by 150 RPM. Then the torque is equals to 4201.69 pound inch. And after that, we can now compute for the diameter. Since we have torsional deflection, we can use this formula. G. And we know that G is equals to pi over 32 e raised to 4. D is equals to 32 multiplied by torque times length. And here is pi, the torsional deflection, times the modulus of rigidity, raised to 1 over 4. Then substitute the given 32 times the torque of 4, 201.69 pound-inch, multiplied by 12-inch length, all over by pi, the given of torsional deflection 0.06 degree. Then we need the torsional deflection to be in rad, so we need to multiply it by pi over 180 times 12,000 times 10 raised to 6 psi raised to 1 over 4. Then the diameter is equals to 2.53 inch or 2.5 over 8 inch. The answer is letter C.
For threaded members, there's a bolts and screws. Bolt is meant to be used with a nut and it is tightened by torquing the nut, while the screw is designed to be used in either a preformed or threaded hole, or it is capable of forming its own threaded hole. There are types of bolts like machine bolt, eye bolt, stud bolt, stove bolt, U-bolt, garage bolt, automotive bolt, plow bolt, track bolts, coupling bolt, and there are types of threads. First is UNC, or also known as Unified National Course, a type of threads that are recommended for general use. Second is the UNF, or Unified National Fine, is a type of threads that are frequently used in automotive and aircraft work. Third is the Unified National Extra Fine, or UNEF. It's a type of threads that is useful in aeronautical equipment. And lastly is the 8UN, or the Unified 8-thread series. It's a type of threads that are used on bolts for high pressure pipe, flanges, cylinder head and studs, and etc. There are also a standard form of threads like Acme thread, V thread, square thread, brown and sharp, worm thread, buttress thread, and Whitworth thread.
For this problem, the power screw is lifting load of 4,000 pounds. A 2.5-inch double square thread with 2 threads per inch is to be used. The frictional radius of the collar is 2 inches, and the coefficients of friction are 0.10 for the threads and 0.15 for the collar. The velocity of knot is 10 feet per minute. Now we need to find, for number 6, we need to find the horsepower output. Since we have the given force and velocity, we can now use this formula. The power output equals to force times the velocity. Then substitute the given. Force is equals to 4,000 pounds times the velocity of 10 feet per minute. Then the power output is equals to 1.21 horsepower. The answer for number 6 is letter A. For number 7, for the same problem, determine the mean diameter if the root diameter is 2.063 inches. So now the formula for mean diameter is equals to outside diameter plus the root diameter all over by 2. Then substitute the given. Our outside diameter is 2.5 inch plus the root diameter 2.063 inch all over by 2. Then the mean diameter is equals 2.28 inches. The answer for this is letter D. For the same problem, we have the given and the problem for number 8. Calculate the lead angle of the threads at the mean diameter. So, since we have the formula of lead angle is equals to arc tan or tan raised to negative 1 multiplied by lead all over 2 pi dm. Since we don't have the lead, we can compute for the lead. Lead is equals to, since it's doubles or thread, we can use the formula for lead 2p, or will become 1 times 1 over the number of threads per inch. So L is equals to 2 times 1 over 2. L is equals to 1 inch. Then we can now substitute the given lead angle is equals to tan raised to negative 1 times lead all over by pi dm, or the mean diameter. Tan raised to negative 1, our lead is 1 inch, over pi, our mean diameter is 2.28. Our lead angle is 7.9 degrees. The answer is letter C. So again, for the same problem, we have here the same given, in the question for number 9. Find the efficiency of the screw. So the formula for efficiency is tan alpha, or the lead angle, multiplied by 1 minus F multiplied by tan lead angle again, all over by tan times lead angle plus the coefficient of friction for thread plus coefficient of friction for collar multiplied by the collar diameter all over the by mean diameter times or multiplied by 1 minus F, or friction coefficient for threads multiplied by tan lead angle. And substitute the given. Tan the lead angle is 7.9 degrees multiplied by 1 minus coefficient of friction for thread is 0.10 multiplied by tan 7.9 degrees all over by tan 7.9 degrees plus coefficient of friction for thread plus the coefficient of friction for collar of 0.15 multiplied by the collar diameter of 4 inch. Since this is radius of collar, you can multiply it by 2 to become radius, all over by mean diameter of 2.28 multiplied by 1 minus the coefficient of friction for thread 0.10 multiplied by tan 7.9 degrees. The efficiency is equals to, don't forget the times 100. The efficiency is equals to 27.46%. The answer for this is letter A. So for the last question, for the same problem in same given, we have here a question. Find the horsepower input. So since we already find the efficiency and the power output, we can now use this formula. Efficiency is equals to power output over power input. Then we can derive this and we became power output all over by efficiency. Then substitute the given power output. The power output is 1.21 HP and the efficiency of 27.46, or you can write this in decimal 0.2746. Then the power input is equals to 4.4 horsepower.